So let's continue down this journey. So we are very close now to finishing up on what is data science. So we extracted the signal from this noisy data, right? We got the slope and the intercept. Now I can ask the question, do I understand the relationship between X and Y, right? And the answer is yes, I do. When I change X, Y is going to increase. If I change X by 1 unit, Y is going to increase by 2 units, right? And then the intercept also I can understand in different ways. When X is equal to 0, the Y value is 5, right? So we understand now the relationship between X and Y, but not just qualitatively. That says when X increases, Y increases, but precisely how much does Y increase for a given value of X. So this idea of inferring these properties, inferring the relationship between two pieces of data is called, there's a whole subject here, statistical inference. And then we have to analyze how good is my inference, right? So for example, an example of an inference task is to try to infer if smoking causes cancer, right? So you do the same thing, you collect data, you plug it into something and then infer that there's a relationship between the number of times you smoke per day and the occurrence of cancer, right? So that's a task of inferring relationships between variables. But the second task is, once I have these relationships figured, can we make predictions? What do you think? We can make predictions, right? What do you think we can make predictions?
Yep, we should be able to.
Yes.
Yeah. How would you make a prediction?
Using the model, like for instance, you mentioned about if smoking causes the death.
Yeah.
You can figure out how many people around you, or you have a data set based on how many are smoking, yes. And from there you can find percentage of people might die.
Exactly. But now I'm going to ask a very precise question with our data set. If I give you a value of X, can you tell me the value of Y?
Yes, we can.
Just plug it in, right?
Yep.
So I've written one line, and I'm saying this is all the predictions I can make from my data. Can you see how does this work? It's one line to make predictions. A beautiful one line, yeah? Okay, so anyone want to try to explain, or I will explain this? What is this line doing? Can you say?
That's the line you found out, right? So if you...
Yeah, but what exactly is this operation doing? Okay, just to make my code a little cleaner, Ashish, when you say for X and X, it's a little confusing. Can you say for X underscore I X underscore I, and then put F inside the F, you put X underscore I. So what this is doing is using a technique in Python called list comprehensions. I briefly mentioned it. We didn't use it heavily before. I just did it to show off that I can write everything in one line. Okay, it's a for loop. It's taking each value of X from the list of X's. It's feeding it into the function with the specified values of M and C, which we just calculated, and it's computing the value of Y. Make sense? That's how we make predictions. Take a value of X and give it to the relationship. It's going to tell me the Y value. So if I run this code, shift enter, it will create all the Y values. So we have actually done some predictions now. Okay, how good are my predictions? So now we run the next graph. And there you see, my predictions are on the red line. And all the predictions plotted out. And you can see my predictions are linear because my model is linear. All my predictions will lie on a straight line. The data does not lie on the straight line. But the question to you is this look like a reasonable line? It looks reasonable, right? It looks reasonable. If you're trying to do it, maybe you can move it a little bit up or down, but it looks reasonable. So the idea is that cost minimization process that we used and the code that we wrote is actually pretty good at automatically finding the line. It doesn't need a human. The machine is able to run this code and find the line. Isn't that cool?
Well, I have a question.
Yeah.
This case, we knew that it was going to work for a line because we added noise to the data. But you went the other way, right? If you just have data, how do you know? Because some cases, the line, it's not good to do a line, right? Like, how do you check whether...
So this is a good question. So immediately I'm going to answer you by saying I have actually created an assignment for all of you. So scroll down. So we're going to do this assignment first, right? just scroll down a little bit more, Ashish. So yeah, can you read this lab assignment? So we can go line by line, Vanshika. You don't have to digest everything. So what's the first part saying? Just the first 2 lines.
So it's saying that there's a data science startup and it would like to make salary offers to new employees based on the data. So they have the experience that their employees have and the salary in units of 10,000.
Yeah. So just this units of 10,000, I want to explain. If the data point is 1, it means that it's $10,000. Yeah? The data point is
and if
5,
it's 2, it means 20,000
yeah.
and so on.
Yeah. Okay. So this is interesting. So let's ask the question first of all. Does this seem like a problem that is interesting and solvable?
Yeah, it's quite interesting.
Right? It's interesting that we can just take this data. So normally what do you have to do? If you don't have all this data science, what do you have to do? If you want to make an offer to someone and he has 10 years of experience, what are you going to do?
If that person has 10 years of experience, then that means that he's quite good. So I don't know, but the basic salary, whatever the basic salary is, I would compare it to that.
But how did the problem with comparison? Number one, you have to get data, and it's hard to get salary data. But number 2, if there are 5 people with 10 years experience, do they all have to have the same number? Does everybody with 10 years in certain companies, in certain places, everybody with 10 years has to have the same exact salary? But in certain companies, it's not exactly the same because somebody has advanced training or somebody has some different other property in there. So not all 10-year people will have exactly the same salaries, right? So there'll be some slight differences. So then which number do you pick? Right? Let's say somebody is making $100,000, somebody is making $90,000. Of course, you'll say always pick the lowest number, but that may not be the right answer either, right? We want to pick the best number or something. So this is an interesting problem. There are other problems, of course, that we can create. I just thought we can analyze this. Okay. So what is the exercise for you? That's in the next 2 lines.
We have to create a linear regression model and calculate the slope and intercept for the line that best fits the data.
Yes.
And then
so before you go to the next one, let's ask the question: is that doable now? Do you have enough knowledge to do this?
Yeah, so I just had one question that there is no noise in this problem. The previous.
I'll show you where the noise is in a second. Okay. But you feel like you can at least try it. Let me ask everyone. Ashish, you feel like you can try to do this?
Yeah, sure.
Yeah, Cassandra?
Yeah, but
yeah, we'll see what happens. Okay, so the goal here is not to intimidate anyone or anything, right? The clue is that everything you need is actually in this notebook, right? Basically, and I'll show you. I'll even tell in words, so just to make it a little easier. Everything you need is here, so it's not going to be hard. But what is exciting is that we can take everything we've done so far and solve a problem with it, right? And Practical Python was designed for us to write code and do things, okay? So, okay, let's look at the next line. Can you build a model? Okay, Vanchika, what's the next line saying?
Can you build a model that would predict a starting offer for a salary negotiation if you are given the number of years of experience?
Okay, so you have to write one function. If I say 10 years, it has to tell what is your starting offer, okay?
Yeah.
So the goal is pretty clear, right? Is it clear to everyone? Anyone has any questions about what we are trying to do? No, right? So it's easy. Okay, so now let me show you this question about noise. The last thing we'll do here, and then we can switch to code board. So if you go to data visualization, do Shift Enter. This is my data. So let's look. So the first thing we must do in data science, or as I said before with noise, etc., take the data and plot it. So Vanshika, what do you see when you see this? What can we tell?
The points are very random. They are scattered all over the place, but they are more like defined to a particular region of the graph. I mean, they're not scattered all over the graph, but it sort of forms a line, but it is very, points are very random.
And what is the relationship between years of experience and salaries? When the years of experience increase, what happens to the salaries?
The salary will also increase according to the experience and
But
qualification.
that's what you expect in life. Does my data show this?
Years of experience. Maybe in some points, but not in all of them.
No, because as you go to the right, if you go to the right in the graph, the user experience is increasing in the graph towards the in the x-axis. The y-axis is moving upwards, right? The points to the
Yes.
Yeah.
The salary is also increasing
Yeah.
as the experience of age is increasing. As we can show in this graph, you can the points are scattered over here.
Yeah.
As the experience are the age is increasing.
Yeah.
Over the years, the salary is also increasing.
Yes, it's increasing, right? It's the
Yeah.
point is sloped upwards like this, right? If it was sloped downwards, that means it's decreasing, right? But there is no line, there is no slope. It's a bunch of points. So we are just using our human ideas to try to draw a line through these points and say that line has a positive slope. Yeah. But
Yes.
our goal is to find exactly this line, or your goal is to find exactly this line. Find the slope of that line and find the intercept of that line. And as soon as you calculate this line, we can start predicting salaries. Does it make sense?
Yeah.
So now,
Yes.
Cassandra, since you're looking at this, I'm giving extra clue here. Everybody can use this clue. All you need to do is repeat the analysis we did before. But instead of calling it years of experience and salary, you have to call it X and Y. Right? If you replace the X and Y we used before with these two data points, just run the whole thing and you get everything you need. Right? And of course, so what I want all of you to do is go back to this notebook and just think about all the discussion we had today, step by step, right? What was the idea? What was the cost function? What was minimizing? Then we have a little piece of code that actually computes something. Look at that code again. And then once you've understood all that stuff, then you come and you take this data and you feed it back in there, and it starts to solve the data science problem of predicting salaries given years of experience. Okay.
Like there's another example, Cassandra, like you can see that the attendance versus the grade received in the class. You can see that if there is any relationship between that, the students who are attending your classes versus the grade they received. And based on the last 3 or 4 years you have taught, you can get some model. And then based on that, you can predict that what will be the grade of a given student.
Yeah, it will be very interesting, right?
Right.
No more grading. I can just do that to not have to give grades. Automatically generate.
Yeah, auto grade.
Auto grade, right? You just see the attendance and give them a grade.
Yes.
So you don't even have to take the exam. I can predict what score you're going to get.
Right. So you can apply it a lot of places, right? The number of hours worked on a given course material versus the grade received, or
yes.
So it makes sense. And let me talk to Vanshika, Siddharth. Vanshika, do you understand this thing? It may be a bit advanced, like it's not a Python specific thing which John is teaching today. It's a lot of people wanted to see what a data science looked like. So this is a preliminary, it's a preview of what goes in. It's like the starting model, right?
Yeah,
so,
yeah. Actually,
but very useful at the same time.
Yeah, actually, I was going to ask all of you, do you start to get a flavor? So we can discuss now a little bit data science. Then I want to show you how to submit your assignments and so on. So yeah, so let me just pass around the room. Do you get a flavor for what data science could be, how we use data, how we create models, how we predict? Do you get a flavor for this whole story? Maybe start with Vanshika. What do you think?
Yeah, I mean, I understood the whole thing, the data analysis thing, and what all can we do, and how useful it is, and how Python can be applied to solve the data science problem. So yeah.
Very cool. Very cool. Siddharth, what about you?
Yes, sir. In practical life, it is directly proportional to each other. But without the data analysis that in Python, with using Python, we can apply on that particular data science with the data analysis. Yes, we can use.
And is this interesting? Would you like to do this, or it's like, oh my God, it's a lot of work?
No, it's not like, oh my God, what is the work is. It's interesting.
Okay.
It's quite complicated, but it is interesting.
Yes. Ashish, what about you?
I'm just loving it. So I have some practical usage. I can already start thinking of it, which I want to start putting into these models now. But
you want to tell me something? We can talk about one. Give me one practical example.
So if I had to take practical examples, so I'm in a client services team where we get a bunch of inquiries from our client, and the way I want to do it is I want to reduce the noise where inquiries which I don't want to spend more than 5 minutes. I don't want my team to spend more than 5 minutes. So I want to bring those kind of inquiries and have a model where I can, moment the inquiry comes in, I can predict how much time I should be spending on, or my team should be spending on. So that's my practical usage.
So that's a very good one. I want to say that an example of that is you could actually say, if you had historical data, so this is where data science starts always with having good data, right? If you had historical data, for example, of a client who calls in, number of minutes spent with the client and amount of business generated, right? So client comes in, you talk for 10 minutes and he's going to buy a mutual fund. The client comes in, you talk for 10 minutes, he's going to execute a trade or whatever. You can actually track from the number of minutes spent to the actual, or how his balance grows or how much investment he does with you. If you have this data, then you can immediately build a model like this and say, you know, for these clients, you spend less time because they're going to talk and talk and talk, but they're not going to invest anything. You see what I mean? Like you can actually apply this to predict how much business you're going to generate from how many minutes of time, for example, right?
Yep.
So, yeah, but of course, then you have to go back and say, do I have the data? So I want to highlight this to all of you. That's why little bit data science is challenging, right? Sometimes you don't have the data. You have the number of minutes spent with the client, but you don't have the outcome because it's in another system or we cannot track it directly or various challenges. So we have to use a lot of common sense and practicality to also understand which data I must collect. Then you must solve the problem of how to collect it. Then only we can run this model and do something useful with it, right? So all these things have to be solved. But of course, the practicality is clear from this discussion already. I'll ask Cassandra now. Cassandra, what do you think?
I think it's very interesting, the applications. In terms of the code and the math, I'm a little overwhelmed, and I feel like I can kind of follow. And if it's exercises that are similar, and I can copy and paste, but I don't know if I could have understood it from before.
Yes. So what I want you to do, Cassandra, is just follow this notebook once. Next time when we all meet, I will say this to all of you. Try to convert anything that you know to be sure of into a question. Right? You say, oh, what is the cost function? Can we understand the cost function better or different? Give me some clues. Even I can prepare some material for you. What I'm trying to say is I didn't put anything in here that's supposed to be complicated. If anything feels complicated, it's for two reasons. One is you haven't had enough time to absorb it. And two is because I chose to write something in a notation that maybe makes something a little bit more confusing than it needs to be. So if I write it differently or draw a picture or something, you're going to understand it, right? But still, I want all of you to try to tell the story in your own words. And when you get to a part of the story where you don't understand, start from the beginning. What is noise? What is the relationship? How do I draw lines? What is a line? Blah, blah, blah. Tell the whole story. And when any part of the story feels a little bit like I can't really tell this story well, come back and just ask me. I understand all this, but here is confusion. I understand all this, but you wrote some expression like this. It doesn't make sense, right? So challenge what I said with a question, right? And I'll draw a picture or give an answer that will make it easier for you. Okay, I don't expect in one setting you should see this because I gave you something very powerful. This is 200 out of 100 years of mathematics and human experience and everything in one place. But what I hoped for sharing is, hey, it's not that complicated. It's not that intimidating. We can go there. And at the end of the day, the code and the analysis is not thousands of pages of code and analysis and all that stuff, right? So I simplified it a little bit. So we'll discuss this more. Kiran, what about you?
Vijay, I've been able to understand some part of it, the mathematical part, and then I lost connection for 5-10 minutes.
Oh.
So it is okay. I'll go through it once and then try to understand. The only thing I have not been able to make out is that how a real data and the outputs of the real data I will be able to relate with this line.
So did you
while I did the calculations to a good extent? Yes.
No. Did you miss the part where we talked about the employee data?
Yes, I think yes.
Yeah. So actually, I should just scroll up a little. I can just actually what we have on the screen, Kiran, is is basically employee data. You can go to this section in your notebook and you can read it. But while you're reading it, Ashish, you can show the graph again one more time. Yeah, this is actual data, Kiran. Or I won't tell you the secret behind this data, but this is kind of data, right? It looks like real world data. It says how many years of experience the person has and how much salary they make.
Okay.
And our job is to find out the relationship between experience and salary. And our job is to predict the salary given the experience.
Okay, so most of the things can be done on the same straight line or model thing or scatter plots.
So now it comes to what Cassandra is asking also, right? Is everything straight lines? Okay, and that really takes us into the bigger field of this discussion, right? I made it very simple. And the answer is, first of all, so there are many ways this problem gets more sophisticated in life. First of all, not everything is straight lines. So we have a generalization that tackles curved lines also. That's not too hard, but we can talk about it, right? Second is, I did only one-dimensional relationships. For example, there's employee data. Employee, it just depends on years of experience, right? But maybe there's another direction in which what is the maximum degree they have. Maybe those with a master's degree get more salary than the guy without a master's degree, or some other criteria, right? So then the data starts to become multidimensional, right? So if it's not one dimension, this is one dimension, one value X and one value Y. Now you can have 15 values X and one value Y, right? 15 variables can predict one value. So we have to now expand this into that multidimensional space. So what would we do? What replaces a line? So let's do the two-dimensional case, easy to visualize, right? So now I have x1, x2, or whatever. Yeah, x1, x2. I have two values, and now I want to predict the data has one output. Okay, let me make a bad data set, but just as an example. Is there any correlation between height and weight and salary? Okay, so I collect some data set. I go and find everyone's height and weight. By the way, I say it like a joke. It turns out that taller, I think I've seen a data set where taller men actually make more money.
Actually, I was going to say that. I had seen that example. I read in some document that.
Vijay,
kind of
even I
creepy,
agree
but
with
it is
you on
true.
that thing.
Yeah. So we can challenge all these things, right? Interesting sociological thing. If I asked you, are you going to pay someone because he's taller? You're like, no, I'm not paying more because he's taller. but apparently those things are there in the data. But anyway, but the question now is, if I take height, weight, and salary, that's the salary is like a XYZ, right? I don't know how to show well. So there's height in the x-axis, weight in the y-axis, and then put the z-axis going vertically. Imagine the three walls of your room as the axis. So now, what happens to the line? What does the line generalize to? The line generalizes to a plane, right? It becomes like a piece of paper. It's a two-dimensional surface. And the points actually live in 3 dimensions, but we are trying to draw a two-dimensional surface through the points. And then we want to find the best two-dimensional surface that fits the data. So this can actually be generalized. So we can do multi-dimensional case also.
So can I ask one thing?
Yeah.
Yeah, with the help of the data science by using Python. Okay. Yeah. As we know, there's a practical explanation in the last few years that India is facing that the problem of insolvency and bankruptcy in past few years, as we know that.
Yes.
So with the help of the data science, can we find out the relation between as we show in this graph, the line of regression, the relationship between X and Y, by plotting X as a number of people taking loans, and by plotting on Y, that number of people actually not covering up the deficit of that loan.
Yeah. So this is a very well-studied data science problem, by the way.
Yes.
I'll tweak your problem a little bit. Okay. So the data science problem is, if I give you some data about a person, first of all, we'll decide what data we want later. If I give you some data about a person, can we predict if he's likely to pay his loan or default on his loan? Make sense?
Okay. Yes.
Yes. So this is a well-posed question. Immediately we can say, okay, what data? So let me ask you, or let me tell, or let's ask Ashish. Ashish, what data do you want to use to predict if a guy is going to default on his loan?
For me to predict if the guy's gonna default is I need to know his salary,
Okay.
his or her credit worthiness, that making in past if he owns any credit card or any
Okay.
cars or vehicles, automobile.
So previous loan payment history.
History and his salary history, how long he's been working on. So the normal thing which bank generally ask.
Yeah. So these are examples of data we could collect, right? And usually that's what is done by them.
So we can use.
No, I'm just saying that this is how it's done. So when you go to a bank, you want a loan.
Yeah.
They ask all these questions that Ashish said, right? They ask salary history and loan payment history. Then they take it in the back room and they build a model. And in the model, it will say how likely is this person going to default or not. If it's very likely that he's going to default, they'll reject your loan application. So this is a very classic data science problem. Okay. But the only thing I will just say, it's very, very advanced what I'm going to say, but just to maybe get you excited about coming back and learning a little more math and visualizing and learning data science eventually, is that this particular problem that we brought up about loan defaulting, the Y value is actually not a continuous value, right? Is default true or false? It's a Boolean.
So it's lie.
Yeah, it's a
lie in that region.
Yeah. So why? No, not just that, but it has only two values. Either he defaults, we're going to predict either he's going to default or not default, right?
Not default. Yeah.
So that falls into a class of models. They are classification models, and if you generalize regression, it will become logistic regression.
Okay.
Yeah, and we can also use very advanced models like neural networks to do this, right? So there are many models that can be used, but the problem that you defined is definitely a data science problem that we can have reasonably good success with, right? Quite good success. If you have a lot of data, we can be quite good at this. So lot of practical
things can be applied over here.
So Kiran, so I think we discussed a little bit of practicalities, but do you see it?
Yes.
Okay.
Yes, we did.
Okay, so let me pause and say, so do we understand? So my goal was to give you a flavor of a particular data science model building exercise with a simple model. I left you with an exercise to go and analyze some data, which looks kind of real. So we'll see what we get. Next time we can discuss the analysis. And I give you a flavor of how does this generalize and get bigger and so on, right? And of course, along the way, I pointed out that maybe we have to spend time just learning some of these tools to manage. Like I use NumPy here, I use Matplotlib for plotting. We have to take dedicated time. Everything I made easy because the code is there and it's doing what we want. Yeah. But suppose I ask you, hey, I want a 2-dimensional data set and I want to visualize it. You won't be able to do it. So we have to take a few hours to learn specific techniques to manage more the data, to visualize the data. Same thing to write these algorithms. You have to learn a little bit of math, etc. Right? So we are creating separate courses to deal with all this stuff. Hopefully, you guys are interested in those things, and we can continue this journey.